So welcome everyone to today's webinar. Thank you very much for joining us. I'm Laura Broderick from the Building Centre and hosting today's Retrofit Talks, which is all about the Entopia Building with our partner on the programme, Ecological Building Systems. We're going to be hearing from the UK Technical Manager, Neil Turner from EBS, and Neil has invited Mark Martinez from Archetype, a senior architect who worked on the Entopia Building project, to also join him in the presentation section today. So I hope you're looking forward to hearing more about this fantastic project, which is also a case study in the Retrofit 24 exhibition here at the Building Centre. So if you can make it to London to come and see the exhibition, see the case study written up and see examples of some of the materials and products that are going to be discussed today, do come and see us. But for now, for the webinar, the format is Mark will be presenting first on behalf of Archetype Architects and talking about the history and the approach to the project, the building having been a 1930s telephone exchange in Cambridge. So Mark will speak for about 10 minutes and then he will hand over to Neil, who will talk very much about the ethos and systems and supply chain of ecological building systems and how they brought those natural and sustainable building materials into the project for things like the insulation and other sort of systems there. This is part of our Retrofit 24 series. We are recording the event today, so if you do want to listen back or share it with colleagues, it will be on the Building Centre's YouTube channel shortly. So I think that's enough from me. I think I will introduce Mark now, Senior Architect of Archetype, to come on screen and we'll hear from Mark. So thank you, Mark.
Thank you. Welcome. I'll just share my screen. So I'm going to give you a very quick, and hopefully it won't feel too quick and a lot to pack in, very quick introduction to the project. So I'm Mark Martinez from Archetype Architects, Senior Architect, and I was involved during stage 5 delivery and stage 6 and 7, which is ongoing. So this project it's a pioneering project to transform One Regent Street into the Entopia Building through an exemplar low carbon refurbishment, which we hope will reduce the carbon emissions by more than 80% over the next 100 years. And it's to provide new headquarters for the Cambridge Institute for Sustainability Leadership, to demonstrate the Institute's core values and explore how the existing building stock can successfully be upgraded to tackle the climate crisis. And this is the building as it looked as we took it over. So quite a unremarkable solid masonry, timber sash window, telephone exchange. It's not listed, but it is within a conservation area, and highlighted as a building of merit. So did have some difficulties during planning, which I'll touch on, but this is what it may have looked like at one point. As mentioned, built in 1939. And over the years, it's had some work done to it, some extensions and adaptations, mainly to the rear. The front has remained largely as existing. And some of these interventions created some headaches during construction, especially around the roof detailing, where we didn't actually realize a lot of this until we got onto site and started opening up fully. So that's a really key lesson learned from this project. And in general, getting as much opening up done as possible when you're tackling a refurbishment project, just to de-risk the project and take out all these unknowns, because it created quite a lot of head scratching and unnecessary pain, but managed to get through it. But as you can see here, a steel frame extension that was not anticipated, the existing building being a concrete frame. This is the upper floor space. You can see some of the more kind of targeted opening up that was done, but quite a dingy space, quite a low glazing to floor print ratio. So one of the key drivers was try and increase daylighting, maximize ceiling heights to make these spaces feel better as typical open plan office space on one of the lower levels. There's a bulkhead running around the perimeter of the building, the ventilation system, which really kind of brought everything down and made it feel even more lower daylight levels. We had the existing building's energy metering data, which you can see on the left there, and we were looking to reduce that by over 80% through the Enefit Classic standards. We weren't able to target Enefit Plus or Premium due to restrictions with renewable energy opportunities, although we did have some PVs or do on the roof, which account for about 10% of the building's energy usage. Yeah, on the project, we worked with BDP, Gardner Theobald, and 3PM to develop the design up to stage 3, at which point ISG brought on their team to develop the design and take it through on site. So kind of a DMB setup with us retained client side. And 2 key people at the beginning of the project and throughout really was John French, who brought the brief that we had worked with him on the UEA Enterprise Centre with, very similar from that project, working with Polly Cortis from the Institute, who maintained the ambition and the kind of the drive on the project, keeping it in check and everyone on the same page. Quite a few certification schemes with overlapping areas. So we have Enefit Classic, Well Gold, BREEAM Outstanding, and then on top of that we had some circular economy and circular design principles, bio-based material targets, and embodied carbon targets as well. Yeah, so it being a passive house, we had an MVHR unit, which was located down in the basement. So a centralized system, which had to work with various different space formats, so everything from open plan office, cellular office, toilets, and social spaces. And we moved the ventilation away from the perimeter of the building, kept everything to the core, distributing out where needed with exposed ductwork to really maximize ceiling heights. And it allowed us to insulate effectively around the perimeter of the building. Being a concrete frame, we couldn't go through the floor slabs, so we had to bring the insulation along the slabs. Yeah, and one of the key impacts, or one of the only impacts we had externally to change the appearance of the building and also to improve the internal environment, was on the window design. We were very keen to move away from the existing sash windows, which are inefficient and restricted daylight, and push towards option 5 here, which is clear glazed, triple glazed system. And we demonstrated that that would not only reduce heating demand through the increased solar gain, but also improve the daylight factor as well. And we were ultimately able to convince the planners and the heritage officer in particular that was acceptable. So this is a before and after render, and we also had quite a neat modern window reveal design, giving it lifting the feel of the building as well, bringing it into the modern time. Yeah. Sorry, that jumped a slide. Internally, we were keen to minimize the material inputs in the building and also maximize waste as well. So we retained a lot of the core or the fundamental structure of the building, the raised access floors. There was very little work in terms of new ripping out any partitions and new partitioning. We worked with a lot of the existing spaces. Yeah, so a lot of natural materials. Some of these had to be dropped due to supply chain issues and sort of commercial issues, and a bit of VE, but we were able to achieve good results in terms of natural materials and low carbon solutions. And we found through our analysis that one of the highest impacts, perhaps surprisingly for some, was in the floor finishes. So over the life of the building, in terms of embodied carbon, carpet tiles were by far the highest impacting material due to the carbon in the material, but then also the replacement cycles over the building's life. So we were very keen to move away from that and just to expose the raised access floors where we could and use low impact materials where we needed them. Just to touch on this, because Neil's going to cover it in more detail, but the main strategy in terms of insulation and airtightness was to airtight the existing walls internally, internal insulation wrapping into the floor slabs, and with the triple glazed windows sitting within that insulation zone. In terms of circular economy, we know that working with existing buildings is always going to be better than building new. And we demonstrated there that we only added 197 kilograms CO2 per meter squared, which is well below the most onerous LETI target for new build. And just that similar diagram in more detail, just demonstrating how we had quite a strict hierarchy for material waste. So reduce, reuse, recycle, and in terms of new materials being brought in, virgin where necessary, but recycled and reused materials where we could as well, which we were able to in quite a few key areas, especially the furniture packages and light fittings, for example. Bio-based targets were difficult considering we were retaining the bulk of the building was already there, but yeah, a lot of it was achieved through the furniture interior fit out design, but also some finishes as well. 35% ultimately achieved. And yeah, we've had the first year of energy monitoring and demonstrated that we've achieved an 87% reduction in energy, which is pretty amazing, saving the client a lot of money in energy bills. Yeah, so we're still yet to achieve WELL gold standard, but we're on target too. There's just a couple of technicalities to get over there, but we've got BREEAM outstanding, benefit, the 87% carbon reduction, energy reduction, as I mentioned, plus the embodied carbon targets achieved. Yeah, and it's, you know, truly is an exemplar building, and the client is keen to promote it as such. Yeah. Through open knowledge sharing. And just some photos of some example spaces here. This is the upper floor with the steel frame extension, exposed ductwork, and raised access floors. Open plan office space and the meeting space. Yeah, and just to leave you on this slide, it's not an ordinary building, but it needs to be. Thank you.
Thanks, Mark. Neil, are you good to go? Yeah.
All right, you're still sharing there, Mark.
Yeah, okay.
Okay. So if I go here, so I start my slideshow from the beginning. Well, good afternoon, everybody. My name's Neil Turner, and today I'm the technical manager for the Ecological Building Systems in the UK. And I'd just like to share with you my experiences, how we worked on the project and the nature of the materials that we supplied. In terms of myself, I'm a bit of a weirdo. I'm strange. I'm a scientist by education, but I've worked in the construction industry now for over 20 years. A lot of my experience is manufacturing natural insulation for warm cell cellulose, but I've been working now with Ecological for 8 years. As a company, we're part of the McCann & Byrne Group. This is a family-run builders merchant hardware business, and they set up Ecological Building Systems in the year 2000. And then that was in Ireland, and then in 2006 they set up Ecological Building Systems in the UK. So we're based in Carlisle in Cumbria, and all of the products that we supply are distributed from there. I'm not going to go through all of these, but this just shows our product range. We're mostly about air tightness, natural insulation, and decentralized ventilation. They're the three main systems that we supply. In terms of the project brief, I was approached by Fielden and Mawson. That was the main contractor's architect, so I did most of my work with them. And I'm just going to go through what the project brief was, what the insulation specification was and the outcome, and then really about how we met the targets in terms of insulation for air tightness, the WELL standards, and the use of natural biogenic materials. So these are the targets that we were given. So we have to maximize the use of natural insulation and achieve BREEAM outstanding. Also Enefit, we had to get or recommend a system that was going to get below 1 air change per hour. But also, when you insulate buildings, especially internally on solid brick walls, moisture can be a problem, interstitial condensation. So we had to do a lot of work with Max Fordham, with Woofy software to prove that the whole system was moisture safe. And then we went through a lot of administration to demonstrate that we were sort of meeting the indoor air quality standards set by WELL. And that's all about mostly VOC emissions. Okay, so in terms of developing the system, our initial proposal was to push for our retro eco wall system. And basically, this is a system where you apply an insulating lime leveling coat on the internal face of the wall. And then what you do is you bond on wood fiber insulation. We supply the Gutex range of wood fiber insulation. And then you have a lime plaster finish that's applied directly on top of that. And then you finish off with breathable paint. The system that was adopted in the end was slightly different. Basically, because it's a commercial office, they wanted to have a boarded finish. So what they did, they actually battened over the top, battened through the wood fiber back into the masonry. And then they used a Thermacell board. It says plasterboard here, but it wasn't. It was Thermacell, which is more breathable. So you can see here there's tapes. So there was pre-taping. This is the cork lime thermal plaster, the diathanite, and then this is the wood fiber that's directly bonded onto the wall. This frame actually wasn't fixed through. It was an independent timber frame. It was set back from the insulation, providing a service void as well as a structure to fix your Thermacell board onto. So the results that were obtained, the air permeability was less than 0.7 air changes per hour. As Mark says, the project's well on the way to achieving the WELL standards. It was proven to be a moisture-safe system, and obviously based on the materials, which I'm going to explain, it contained a high level of sequestered and biogenic carbon. But it wasn't just the walls where natural fiber was used, it was used in the roof. So the flexible wood fiber insulation was used in between the rafters and the flat ceiling joist in the roof. And then the airtightness in the roof was achieved by the Proclima Intello Plus moisture variable, diffusion variable membrane. The thermo-jute was also used in internal partitions. It has very good acoustic properties, airborne acoustic reduction properties as well. And obviously, in order to achieve airtightness in combination with the diathanite, you have to do quite a bit of pre-taping of junctions. And also where you've got penetrations through your external envelope, you have to pre-seal those as well. So this is just showing some of the products here. This is the diathanite, the cork lime thermal plaster. So this was all sprayed onto the wall at 40 mil thickness. This is the Thermaflex, and the Thermaroom is a more rigid board. So that was also 40 mil. So you've got about 80 mil of total insulation. And this is a picture of the hemp flax CombiJute with the dog sat on it. I just quickly run through some of the benefits of these natural insulations. So insulation such as wood fiber, it's really good at thermal insulation in the winter, but it also has a high specific heat capacity and a fairly high density. So it actually prevents or reduces summer overheating as well. It can absorb a lot of heat and delay the time that the heat comes in. I mentioned acoustic properties. The products are all Nature Plus certified as well, and that ties in with the VOC, the volatile organic carbon emission. So there's just some benefits of natural insulation. This is just showing the Thermo Hemp CombiJute. This is another flexible product. It's a mixture of hemp and jute fiber. The jute fiber is actually produced from recycling cocoa sacks. So instead of landfilling these bags, they're used to make insulation. The actual insulating lime level coat was diathanite thermactive. So this is a cork lime insulating plaster, and it's actually trifunctional. So it's acting as an insulating level coat. It's also a moisture buffer. The product is very moisture water capillary active, but it's also acting as an airtight layer as well. So it's kind of trifunctional. It has a thermal conductivity of 0.037, and it's very moisture vapor diffusion open. It's got a mu value of 3. And it contains a high level of recycled cork as well. Diason, the manufacturer from Italy, actually recycles cork from wine bottles, and also waste cork from the production of these. So the product contains, it's mostly containing of lime, so it's hydrated lime with a small amount of NHL5 binder. It's got cork, silica, pumice stone, cellulose fiber, diamethic powders, and perlite. The other advantage of this product, if you're in a tall building, it's also Eurofire Class A1. I mentioned about water capillary activity and moisture buffering. This is just showing pictures of how the product can absorb a bit of moisture and then release it when the climatic conditions allow. And it's actually protecting the wood fiber as well internally. So in terms of embodied carbon, Mark has gone through all of that, but I'll talk a bit about airtightness. Obviously, cork lime plaster is airtight, but what you have to do is pre-seal junctions, things like wall to floor. So this is just showing the tape that was used. It's a Proclima tape, Contiga Solido SL. So basically you prime and then you apply the tape. Now, the other product that was used to pre-seal was a liquid product. We actually supply Proclima's Aerosana Viscom. So you can either brush this or spray it, and then when it dries, it gives you an airtight moisture vapor diffusion variable membrane. So that was used in some situations. This is just showing the window detail where they're using the Isochemy wind framer. And what this blue line is showing is that you're kind of using a tape. So you're pre-taping the wind framer back to the masonry, and then you apply the diathanite and then the insulation over. So it's always a good idea to pre-tape junctions and openings before you line plaster barge over. And this just shows a picture of after the wind frame has been fitted. Okay, in terms of moisture assessment, as I mentioned, with internal insulation on solid wall, moisture is always a concern. So we did a lot of woofie modeling with Dave Lamb from Max Fordham. And basically woofie is the recommended type of software. It's using the EN 15026 standard. So it takes into account not just the moisture vapor diffusion resistance of materials, but also capillary action, liquid suction, how much wind-driven rain gets sucked through the brick, for example. It also takes into account of radiative moisture movement. So in the summer, when the heat beats down on a wall, moisture can actually move from outside to inside. And with this sort of breathable insulation system that we adopted, that moisture can actually harmlessly come back into the room and not build up in the fabric. So this is the laser method that you get with a standard U-value software program. It's not really suitable for these kind of buildings. So this is just showing the percent humidity at the interface between the Gutex wood fiber board and the diathanite, and you can see your average humidity is way below 80%, which is very, very safe. And you can see here that the temperature is always above the dew point temperature. Your moisture content at these interfaces are also very, very low. If you're below 18, then that's fine for wood fibre. So we did a load of work with Max Fordham on Whoopi. This is just showing the water capillarity of different natural materials. So the one on the left is the wood fibre, and the one on the right is the diathanite. And you can see that the diathanite has a certain degree of water capillarity, so it can absorb moisture.
Neil, that's you taking 13, sorry. 13.
Okay, so I've got about 3 minutes to go, 4 minutes to go.
Perfect.
Okay, so the well standard, this is all about indoor air quality. We had a very administratively onerous task to prove that all of the materials we supplied were properly tested for VOC emissions. And the standard is ISO 16000 Part 9. So basically, you take a sample, you put it in a chamber, and then you pass air over it, and then that air gets pushed into a gas chromatograph with a mass spectrometer analyzer. And the beauty of this, you can detect really low levels of VOC. So you're looking at very low microgram per meter cubed or parts per billion. And the well standard actually works with the Californian Department of Public Health in the US. So there's limits on the total VOC, but you've also got limits on individual compounds. So you see all of these compounds here, and you've got allowable maximum concentrations. So, and I mentioned here, it's all signed off by Arnold Schwarzenegger, because at the time he was actually the governor of California. Now, it surprised me, but California has the most stringent indoor air quality rules for buildings in the world, which I didn't know at the time. So this is just showing some excerpts from test reports for the Proclima products, diathanite, and natural insulation products. A lot of the products as well that we supplied are Nature Plus certified. It's a very similar scheme to the Californian scheme, but there's 1 or 2 slight differences in threshold limits. Okay, so in terms of lessons learned, probably the biggest one for me is that when I went to site before the project had even started, I told our director, oh yeah, there's no problem with a full truck access into the site. Well, actually, that wasn't the case. You could only get a 7.5 ton vehicle into the site. So we had to work very hard to take bulk storage down to a builder's merchant in Cambridge. And then we're minimizing the environmental impacts of transport delivery, because we're only traveling short distances with short trucks. So in terms of summary, the diathanite thermactive insulating lime plaster and the Gutex and the thermo combi wood fibre, natural fibre, it made a really significant contribution to the targets set, whether it be on airtightness, on natural biogenic carbon with recycled content, and also complying with airtightness, as well as achieving all of the thermal targets. And just to finally say, which is what Mark was saying as well, this is a quote from Carl Elefante, the former president of the American Institute of Architects. The greenest building is the one that already exists. So wherever possible, it's always better to thermally retrofit and upgrade buildings rather than demolish and rebuild. So that's a very quick snapshot. And this is just our contact details if you'd like to get in touch with us. So that was a very quick summary, and that concludes my presentation. Thank you.
Thanks so much, Neil. And I'll invite Mark to come back on camera as well. Yeah, great. Amazing. It's great to have you present alongside each other as well. So to get the kind of the understanding of the context of the project and then all the detail through. So thank you both. We are going to take questions. As I said at the beginning, you can put those to Neil and Mark in the chat box. So do start to think about what you might want to ask of them and type those in, and then I'll address them to our presenters. But just to kick off, a few things from me. I was intrigued, Mark, about a lot of the kind of energy savings you mentioned to do with the fit out, you know, the sort of the furniture, the carpet tiles, the lighting. And maybe it's something we haven't discussed too much within our retrofit kind of conversations to date. So I wondered if you could just sort of say a little bit more about the role of the architect and kind of sort of thinking through some of those decisions as well. Do you have influence on that? How do you kind of see that going?
It's a really tricky, because even if we have the ideas and the ambition to reuse products and trying to build that into the contract, the reality is you have to find those materials somewhere, and that either requires a robust kind of network or structure in the industry to facilitate that, which requires storage, distribution, all these factors, or you have to be opportunistic. And you also require a design team and a contractor team who are open-minded and proactive in that as well. And we were lucky on this project. We had a contractor, you know, there was always an attitude for collaborative working, even though it was effectively a DMB kind of situation. That was kind of built in. There was a charter on this project that kind of covered that. And the contractor was proactive, and they, you know, opportunistic. We got lucky with some things. So reused lighting, because they had another project that was stripping out lights from a brand new office. It was like a, you know, first fit out company moving in, didn't like the lights, but they were brand new. So we had hundreds of lights. So we managed to get them stripped out, retested, recertified, and adapted for this building. We had a reception desk that was gleaned from Netflix refurbishment, and we had steel work for the PV array from a film set. But all of these were chance opportunities that came about at the right time. I'd say it's very hard. There isn't really a robust infrastructure for reuse in terms of acquiring reused materials. I mean, there are, but at large commercial scale in particular, it's difficult. In terms of waste, you know, there are charities. We managed to get a charity to take all of their unwanted furniture out of the building to donate, and the client was also able to store a lot of it and get the interior architect to you know, to refurbish and reuse a lot of that stuff as well. So yeah, you know, we were successful on quite a few fronts, but it's challenging, I'd say.
Yeah, and it's not a kind of big systematic approach within the university already with the systems there to kind of, or a commercial scale system even to do that. So yeah, no, it's interesting to hear more, and it's great that you achieved what you did with it. So well done. Questions are coming through. So this one is from Lucy. How much was done in the way of structural alteration? So that's probably one for you, Mark.
Yeah, very little really. So the existing building was concrete frame. It was quite robust. It was, you know, we didn't need to do any really fundamental changes. You know, there was nothing in the way of underpinning or kind of repairing the structure. There was a surprise with the steel structure, but again, it was just stuff to work around. Any adaptations to layout were non-load bearing element partitions. We didn't introduce any new windows. We just used what was there originally. I'm trying to think if there was anything in particular, but I do remember it being minimal. Yeah. So no, not really.
Okay. Great. And one for you, Neil. This is in from Jason. Do you see any future issues with the circularity of the wall materials because of the bonding, and therefore?
Yeah, that's a good question. There's two options for fixing wood fiber. One is you can either bond with the adhesive, a breathable lime-based adhesive. The other one is you can actually fix with thermally broken screws. And what you have to do is fix all the way through back into the stone. The only problem with that second approach is on this particular project, you're then risking puncturing your airtight line.
Yeah.
But what you can do with wood fiber, you can definitely cut away the wood fiber. And wood fiber can be used as a mulch. You can also mill it, and you can use it as loose fill wood fiber that's blown into voids and things like that. Lime plaster is a bit more tricky. Obviously, you're not really going to be able to recycle that at the end of life.
Yeah, so some you can, some you can't. Yeah.
Yeah.
Okay, great. I think this is a collective question. So from Laura, what were your lessons learned from the project? I don't know, an individual one, and then maybe something as a team, like whether there are any sort of team debriefs and things you can share. So Mark, do you want to kick off with your lesson learned first?
Yeah, well, the big one that I mentioned was early opening up. On any refurbishment, the more you can understand about the building, the more you can uncover at an early stage, the better. You know, there were a few things that caught us out on this. The steel frame that I mentioned, but there was also a service trench that ran around the perimeter of each floor plate that we didn't anticipate, and it created a real problem for airtightness detailing to overcome that. There was also some issues with the basement tanking as well, and some services that were unanticipated. So that's a big one. And, you know, understandably, the clients aren't always willing to do that, because until things are secure and, you know, the project's really underway, they're not willing to spend the money and to take the risk to undertake that work, which can be quite extensive. So, yeah, it's a bit of a chicken and egg one, but I would always push for it as much as possible. Yeah, maybe that I'll just leave that as my
take that
one.
as your one. And Neil, one from you?
Well, apart from the one I mentioned where I kind of misled our director a little bit.
Is Penny listening in now as well?
I don't know. She's forgiven me a long time ago.
Good.
Yeah, for me, the biggest one really is this idea of adopting a system where you don't have to board. And we're actually working on another project with Archetype, whereby they're actually line plastering onto the finished board. And the concern about this is that where you've got things like heavy objects like radiators and things like this. So we're now actually supplying a new product. It's called Bosig Phonotherm, and it's an insulating patras. So in other words, you can make the behind the patras airtight with the liquid membrane, fix the patras, and then you can then insulate around and over, and then when you want to fix heavy objects, you just fix them into that patras. So in other words, you haven't got a thermal. So that's one sort of development, if you like.
Okay. Yeah, well, that's good. There's a lesson learned and something coming of it. And what about as a team? You said there was this charter, Mark, about collaborative working. Was there like a kind of really sound debrief and things collectively?
Yeah, so this charter, I think it's the university's standard practice to have a charter, and this project needed one, but that also the client, you know, having the right people like Polly Curtis on the client side, like John French, who was the kind of brief consultant who helped them develop the brief, you know, to really steer the project and keep everyone, you know, working on this in the same direction, everyone on the same page, to keep that the vision, the original vision alive, to make sure that the kind of ambitions and the targets are understood, are being met and monitored. You know, so you know, it comes down to people and roles, but in terms of contracts as well, you know, choosing the right contract and the team to work, you know, the contracting team who are open-minded, proactive, who are engaged and willing to take risks, and to work collaboratively, you know, and ISG in this case did that for us, you know.
Great.
So yeah, it's a bit of both really, having the right people, but also having the right kind of contract structure there to support
Back it up. Yeah. And that's probably quite a nice segue into the next question, which I'm going to shorten because it's a long passage of text typed in here. So this is from Martin, who's the chair of planning at Cambridge, and he was asking about that vision side. So saying, did you have a plan to convince people of your vision? So do you want to say a little bit more about that kind of people in place part of a building project, I suppose?
In general, or specifically on this project?
Well, specifically on this project, but Martin elaborated a bit more. You know, you've talked about the science, but there's obviously people, planning and politics behind retrofit projects. So like, how do you communicate a vision, maintain that vision, and bring people on board with it?
Yes. Okay. Well, in this on this project, I guess the fortunate situation was that the client was already driving the ambition. They were already keen to have an exemplar project that there could be an exemplar for the rest of the industry and to promote it that way. So they always had that plan to do something that was pioneering and also to use it to influence and to change the industry, which is what we're doing and has been done very well. In general, though, if you don't have that kind of energy and enthusiasm to start with from the client, then yeah, I mean, we're doing this all the time with low energy, fabric first build approach when you have clients that don't necessarily understand the benefits or have financial concerns around, oh, passive house can be expensive and stuff. By the way, we've proved that this project was cost neutral to a standard retrofit. Yeah, it takes some convincing, but we have an evidence-based approach. We have a lot of data and research and experience to demonstrate that there are benefits to building low energy, low carbon. Yeah, it's really project by project, client by client. Everyone, there's always a different approach.
Yeah.
And a certain different levels of convincing needed. What was the second part of that question? You said it's non-project specific.
Yeah, I think we can probably leave that one to move on, Mark, if that's all right. Only because we've got 3 more questions and only 3 more minutes. So I'm conscious that the people probably will want theirs. But no, great answer and a great question from Martin. So this one's from Anthony talking about the carpets. So the carpets are quite useful for acoustics, but clearly bad for embodied carbon. Did you have to add in any other acoustic absorption?
Yes. Floors have a lower impact than ceilings and walls in the right place, but yes, you're right, they do. So we sprayed the soffits, the concrete soffits of each floor plate with Sonospray, which is a cellulose-based blown product, and it comes in different levels of fluffiness. We call it fluffy clouds. Love it or hate it. We like it. We think it looks quite nice. And yeah, most of the surfaces, the ceiling surfaces were sprayed with that. So that's doing a lot of work on acoustics. And we had some acoustic fabric panels in key spaces as well, mainly meeting rooms. And through those 2 measures, plus with some soft furnishings and planting and other things breaking up the space, the acoustics, have worked, and that's all we needed. So it hasn't been an issue.
Yeah, just quickly, in a previous life, when I was working manufacturing cellulose, we used to manufacture a whole range of other fibers for other applications, and recycled carpets was one of the feedstocks that we actually used to make a product. So if you like horse racing, I'll give you an example. If you look at these artificial horse race tracks, they actually use recycled carpets as one of the ingredients.
Yes. It's a system, even if it's not the long-term solution, right? Okay, yeah. Great. Well, thank you both. It is 1:45. If anyone has to leave the webinar, I appreciate you having to just jump off the call now, but I will put these 2 final questions to you for those who can stay. So this is from Armand. Did you have to retest all of the raised access floors? And if so, who surveyed and certified the system?
I don't believe there was any certification or testing that was done. They were kind of brushed down and refinished because they were very scuffed up and dirty from the construction. A lot of them were lifted, set aside and relayed to access underneath. So yeah, but no, generally there wasn't. I don't think there was a formal process or anything there. They were just cleaned up. We snagged them. Any that didn't meet the right standard, we got them to redo or replace, but no.
Right. Okay.
And they're not as slippery as you might think. So they work quite well.
Great. And final question, it's probably a good question for both of you as well for ending. This is from David John. When specifying in terms of maintenance, how did you approach the design and build so that the building can be easily maintained in the future? I don't know, Neil, do you all together or
if you went for Neil, maybe first.
Yeah, I mean, it comes back to one of my first slides. Obviously, if you have an independent frame internally with a board, then that gives you, a service zone. And also, if you want to replace the boards, it's easy to do it. So that could be one. aspect of the design that made maintenance easier, for example.
And I'd say, I mean, there's maybe different ways to look at this question, but say in terms of the M&E, like the ventilation heating design, is, you know, we've exposed everything pretty much, and a centralized MVHR, so it's a matter of servicing that unit, but everything else is exposed, so easy to access.
Yeah.
We've limited the material finishes and, you know, non-essential materials, so there's less to maintain and replace in general. There's not much in the building that's not, you know, that's non-standard or that would have any particular maintenance requirements or cycles that I can initially think of, other than, you know, that it's Enofit and it has a, you know, that MVHR system. Yeah.
And making it as easy for, as you say, the facilities maintenance team and then the building users to use it efficiently, and just good quality products. Yeah, not replacing too much. No, it's great. Fantastic project. So pleased we've got it in Retrofit 24 exhibition, and appreciate you both taking the time to talk about it today. So the recording will be shared for those of you who want to watch back or pass it on to colleagues. As I say, come and see the Retrofit 24 exhibition. Ecological Building Systems have supported Retrofit 24 and previously supported Retrofit 23. So thank you to them for partnering with us. And yeah, keep in touch, follow the Building Centre's website for the further events we've got for Retrofit 24, 2 more webinars and a panel discussion on the 10th of July. If you can join us for those, that would be great to see you. But final thanks to Neil and to Mark today. So take care. Bye.
Thank you very much.
Thank you.
Bye.
Thank you.